Yeah, hello everyone. Hope you've all got beer. Hope you're all settled in. We're going to go on the crazy train ride of serverless, the framework and the architecture. Hooray. Okay, so most of you have probably seen the term serverless scattered around the web somewhere. You've seen it in some hacker news thread, or you've seen it tweeted by some guy with a beanie riding a fixie. You're like, oh, what the fuck's this? I have no idea. Wait, can I swear here? Too late now. So you sit around and it mills around the back of your mind, you put into Google Trends, and you go, oh no, it's got a hype curve. Soon people will want to have it on their CVs, and I need to get involved because I like being employed. So you have questions like, what is a serverless? How do I get one? And is this one of those things that we all think is a good idea now, but deeply regret later, like OOP? Answers to this and more coming up. All right, first a bit of disambiguation, right? So there is serverless, the framework, and serverless, the architecture style. Serverless, the framework, helps you make applications using the serverless architecture style. But to understand what serverless, the framework offers, we first have to talk about serverless, the architecture style. With me? Great. Bit of history about DevOps. So in the olden days, if you wanted to make an application, you'd write your code, you'd be all proud of yourself, you want to share with the world, and then you think about where you're going to put it. So in the olden days, it was a physical machine. Maybe it's under your desk, or maybe it's in the cloud, which is just someone else's desk. You would SSH in, maybe, set up the operating system, put in all the bits and pieces to run your application, which is fine, and you'd patch all the things you need to, and you set it all up, and you set up the SSL certificates, and you're like, okay, that's fine. Then you find, to your amazement, your application is quite successful. You get a second server, and you do it all again. And then you start to think, all right, I might have to write a script next time I do this. So the third time comes around, and you go like, okay, right, I've written the script. But even then, you still have trouble. You still have to update your box. You still have to make sure your security patches are applied. Your Apache config breaks for no reason sometimes. And oh God, the database is on fire because there's run out of disk space again. And if you keep going and your herd of computers keeps enlarging, you end up being a person who only ever has SSH terminals open on the screen, trying desperately to keep all your children from exploding, which is very sad. And if you do it for too long, the madness will grip you, and you'll find you're only ever DevOps from some dark basement somewhere while gripping a bottle of whiskey, like this loser. So let's not do that. Let's do better. So first we thought, let's try virtual machines. They're good, right? Because you can kind of get a snapshot of a OS in a certain state with all your applications are pre-set up. You can just fling those out into the universe and be like, yeah, great. Although, not that great, because you still have to put them on a machine somewhere, and I guess you can have multi-tenancy, that's cool. But you still have to update the virtual machines as well, because they too need to be updated with patches for security exploits and whatever. So okay, let's try one better. So containers are rad. Containers, you can like spring up and spring down really quickly. You can have quick deploys. It's much easier to test against them because they're much easier to destroy and spin up. So okay, containers are pretty cool, but containers are still a bit tricky. You still have to host them somewhere, and they can be quite fidgety to put together and to put together right. I mean, anyone who's tried to set up a Docker swarm will know what I mean. It's not a zero friction process. So wouldn't it be great if you could just chuck your code, just the application bits you really need, into the void, have someone run it for you with no need to think about exactly where it runs, how to scale it? Wouldn't that be fantastic? And wouldn't it be even better if you only ever had to write the bits of the application you actually care about? You don't have to write a registration system. You don't have to write that stupid data layer. Well, with serverless and backend as a service, this could be true. So how on earth does that work? Well, here's kind of a traditional application. Let's say you own a pet store. I stole this diagram from Martin Fowler, by the way, so no one tell him, he's going to be mad. So this is the kind of like traditional architecture. You have your monolith in the center, you have a client, which could just be some browser or some JavaScript, thicker thing, and some database where you store everything, your orders, your user registration details, your login details, as well as everything else you could possibly have, right? And that's fine. How does this look in a quote-unquote serverless world? Something a bit like this. And I might think, Marcel, you idiot. This is much more complicated, but I assure you it's not. So, for example, the only bits we actually talk about, or the only bits we write, are these two, the purchase function and the search function. That's the only thing that's unique about our application. We can get this up very quickly. We use an authentication service that exists, something like Auth0 or AWS Cognito, because how many times have we written or installed a gem or something to have a user be able to put in an email address and a password, get registered, and then log in, and have the email sent to them if they forgot, blah, 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 blah. There's no value in this unless we are the back-end authentication service that we're providing to other people. There's no reason we should have to do this over and over again. That's not the value in our application. Like, if you're building a pet shop, no one cares that your registration works. That's just something you have to do because it's important, right? And things like API gateway, we can use that instead of having to do our own routing, which is a pain in the ass and also something you have to maintain. And once you start to get legacy stuff, your routing get really esoteric and eldritch-like. So let's not do that either. Let's just focus on these two things, the purchase function and the search function. We wrote those, and they are just functions that exist in the ether. When someone calls it, they appear, they run, and they give something back to the client, and then they disappear. If lots of people call it, many appear and then disappear, and you only ever pay for the actual runtime. When no one's using them, they're not there, which is fantastic, because now we can focus on the parts of the application we actually care about, rather than doing another CRUD app with a lot of setup. And it scales infinitely. You won't be working up at night. It just lets you write code in a very granular, non-monolithic style that lets you compose parts of your application very, very easily. More on that later. So serverless architecture, you can focus on the bits that matter. You can go straight to market, because there is a continuing war on speed in development. We want features faster. We want stability and quality faster too. And in the olden days, deploying was just something that you had to do. It was a week-long process. It could go wrong. Monitoring was hard. But yeah, let's just do it like this, because then we can be quicker. We don't have to worry about stuff. We don't have to worry about maintaining it or applying patches, because it's just a small piece of logic that we put in a function. And you get insane hipster cred, which is what we really care about. OK, so you might think like, wait a second, isn't this just platform as a service? And the answer is not quite. So if you use something like Heroku, they offer the ability for you to like have your application hosted for you. So you just like chuck your Django app or whatever at them, and they'll be fine. But it's not quite the same, because it has a monolithic unit of deployment. The great thing about serverless functions is the level of logic is the same unit as the unit of abstraction is the same as the unit of deployment. Whereas with dynos and that sort of thing, it encourages you to continue having this like monolithic approach. So if you want to update something, you're updating it, but you're also pushing all of the rest of the stuff again as well. So it's less granular, and you have less control about how this really works. And you're kind of steered about your technical decisions, because with lambdas and other functional or other serverless approaches, you can easily just use any polyglot languages, and it's great. Cool. And yeah, if you have a PaaS that can just appear and disappear in under 20 microseconds, just call it serverless. So you're infused, and you go to the internet, and you're like, great, I know about this Lambda interface in AWS, and there's like a text box I can paste my code into, right? But then you start to think about it, and you're like, OK, but how my application is more than just one file. How do I bundle it? And what about configuration? And I need to monitor it to make sure it's not doing anything weird. And logging would be great. And when I'm developing it, I need to be able to debug it. And we need to test it somehow, because all these nice little pieces of functionality that are separate functions that can be deployed seem really testable, which is great. But how do I test them? And, well, that's where serverless comes in. It's a kind of a package that wraps all those concerns and makes it very, very easy to have your infrastructure and your code set up so you can launch products very, very quickly, or just experiment, or run infinite staging servers, or whatever you want, really. So let's launch something into the void. Boop. Right, OK, nice. Can you all see that, by the way? Is that big enough? Bigger, smaller? No? Wrong color. Yeah. All right. Well, I changed my editor to white background, black text in anticipation, but I didn't do the same for my terminal. Sorry, people. Next time. Cool. All right. So let's make a thing. All right. So here we go. We're going to use serverless, and we're going to create a node instance, a Lambda, from a template, and we're going to call it the LNUC demo, and it's going to be great. Yeah, that's right. Got that console art. Yeah, so this is it. And you can see that we have loads of cool things in here, like invoke locally, deploy to function, logs, metrics, all that stuff we're concerned about, it kind of takes away. So let's deploy it. And while it's doing that, we'll have a look at some of the code it actually made, because it hasn't made very much. Oh yeah, of course. Restarting computer means... Sorry, I'm going to set my AWS profile to something else. Dun, 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 dun. Great. So now it's up there doing all these things, and while it's doing that, let's have a quick look at LNUG demo, right? Yeah. Okay, so you can see it actually only made a handful of files. So handler.js is just your Lambda function, which says, okay, well, when I'm invoked, I'm going to give you a response that says, hooray, you know, everything's great, I work, I heard you. The really clever part is this serverless YAML, which is the infrastructure part of your code. So you have each serverless entity is like a component that has both the infrastructure and the code as a combined unit, which makes it extremely powerful and self-contained. So just to run you through it very quickly, like you have the name of the service, you have what provider you want, and there's loads and loads of helpful text here because this is one of like the beginner templates. You want to use AWS, you want to use Node. We want to have a function called hello, which is inside handler here, as seen. And yeah, and when we invoke it, when we get to it, we just want to invoke it. Nothing complex whatsoever. Let's see how a deploy is doing. Hey, it's done. So what it's done here, it's zipped up the code, it's zipped up the cloud formation template it needs to make all the different parts of the infrastructure, it's put it into an S3 bucket, it's executed, it's set up all the IAM permissions for your user as well, so your Lambda can now touch all the bits of AWS that it needs to in a very controlled way, and it's ready to go. So if we wanted to invoke it, we can just call the function and get like, hello, back from the internet. There you go. We have a Lambda function. It's live. This is infinitely scalable. We can all go there forever. Okay, but we want to change it, right? And the whole thing about this is like, it's supposed to be this amazing thing that you can just change all the time. It's so continuously deployable, it's unreal. So let's do hello LNUG. Boop, boop, boop. And we just want to deploy the function, so we can do it individually like this, which is a bit quicker because it doesn't do all this stuff like setting S3 buckets or whatever, because that's already been done. You're embarrassing me, serverless. Dun, 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 dun. I am doing this for my phone, right? The internet doesn't work, so be a little bit patient. Okay, well, that's doing its thing. Have fun. Cool, right, so that's basically a very, very basic idea of how serverless could work. But it's not very interesting. Like, it's just an endpoint. We get some JSON back at the moment. It's blah. The really cool thing is that we are updating it. When the dots will finish, it'll have been updated on the internet for everyone. So it's the, here you go. So now if you were to go to the same URL, you get, hello LNUG, way! But you can see how stuff like this will make continuous delivery and continuous deployment completely trivial. You don't have to package everything into a container. You don't have some awful Jenkins pipeline. You just push and your function is updated. It's amazing, right? And you can just make ones with different paths, with different API gateway configurations. So you can have testing and production be exactly the same, but with different URLs. It's really, really flexible and really, really composable and very, very powerful. So let's see something a bit more serious. And by very, very serious is we're going to make an application, this is a lot of business value, that finds people's faces and replaces them with emojis. So we're going to take a picture like this. Here you can see two of today's speakers in this photo. Johnny Arnold has a better costume, but that's quite all right. We'll let him off this time. And we want this to happen. We want to read people's faces, get their emotions, and apply the right emoji to it. Now, you might think, that seems like it's going to be a lot of work. No, we'll do it very quickly. So this is going to be our architecture, right? We're going to have an event in an S3 bucket, which is, we're going to have Lambda listens to an S3 bucket. And when that S3 bucket gets a new picture, it's going to pick it up. Then it's going to shove it towards AWS recognition, which is this new image service that AWS provides. They can do things like finding faces, reading emotions. They can also recognize stuff in pictures, which is really cool. And then we're going to come back with that, and based on that information, we're going to replace people's faces, because we have their position now, and whether they're happy or not, with emojis. It's going to be great. I can kind of just say for a second, though, AWS recognition is magic. Holy shit. This joke is from 2014 about how it's impossible to tell if a picture is a bird of your computer. And it's 2017 now, so AWS is ahead of schedule. Pretty amazing. Now, as an example, I gave it this picture of a sparrow, and it was 97% sure that it was a sparrow, a bird, but I was also 97% sure it was a sparrow. If that doesn't impress you, I don't know what will. Like, this thing can tell species of birds much better than I can, right? Yeah, okay, so let's do some emoji face swapping. All right, so I'm going to take a photo of the crowd because I need some faces. That's right, we're going hard in the live demos here. All right, everyone pull a face. Have different emotions if you like. Perfect, you're all beautiful. Oh, it's still uploading. Come on. All right, well, that's doing that. Let's have a quick walkthrough about how we actually did that. So actually, it's very, very simple. So you have a little handler.js a Facebook.js, which is just the same as before. This was actually very boring code. It's just a bit of CRUD, where we get the image from the event. Here's the S3 bucket being filled up. And we detect the faces of the image. We process the image. We use image magic to just put the emoji on. It's actually like, it's 200 lines, and most of it's boilerplate, like get the thing, download the thing, put the thing, right? It's very, very trivial. The interesting part is how serverless strings all this stuff together. So we have got the same thing as before. So for AWS, we have Node 4.3, but we have a bit more now. So we have all these IAM role statements, which let you have stuff like, okay, for this Lambda function, I wanted to have the authority to use recognition and the detect faces feature. Fine. And I wanted to be able to go to this bucket name and put objects in and get objects, because it take the new photos out and put the process ones in, right? And we can have a bit of like help here, so we can use dynamic naming, just for sake. And as before, we declared the functions that we want this particular serverless to have. Obviously, each different function is a different Lambda. So we have a handler. We wanted to wait at least 30 seconds because this can take a little longer to detect all the faces and do all the processing. We wanted to have a bucket name in its environment variables, which extensions allowed, where the process photos goes, and here's the event trigger. So events can be things like, hey, go to this URL and this fires. But you can also have like other kind of events as pictured here. So here we wanted to look for objects being created in an uploads folder in this S3 bucket. And when that happens, the face swap function gets fired, right? Great. How are we doing? All right, we may have to call short on that demo, unfortunately. It's really cool as well. Like I worked on that hard. It's piece de resistance. Okay, so what we saw there, or what you would have seen, is you actually made something that, like a backend, where you can put in a photo and use these backend services to replace the faces of someone with emoji based on their emotions, which like 3 years ago in the App Store would have been a #1 seller, right? And that's there now. It can scale to whatever many people you want. You can update it whenever you want very, very easily. If you hook that up to some React Native application, you'd be making quids in. So I will say that I did steal this emoji face swapping from a lovely man called John McKim. I'm not that creative. So give him some love. He's a very nice guy. He tweets really cool stuff. So the question is, like, with serverless, like, it sounds great, but is it for you? And the honest answer is there are some drawbacks. So you do have vendor lock-in, right? Although serverless works with a number of services like OpenWhisk, and AWS, and there's loads and loads of plugins. There's a really huge list of plugins that you can use to extend and give serverless even more functionality. It does, like, you will end up somewhere, right? And if you're basing it on services like recognition, obviously you will have some lock-in. And to be honest, the other online services aren't nearly as competitive as AWS. Like Azure is garbage. I have stories about this, many, many stories. Yeah, so Lambdas, they do expire because they appear and then they run that thing and they disappear. The payment for them is based on how long they run, so obviously if you have a really long running process, probably not for you. You do have an overhead increase because obviously like lots of little services have to talk to each other rather than have like one monolithic block of lots of local calls. And one that used to be a big thing is a cold start time. So Lambdas aren't always like primed because that would be really infeasible. So sometimes they have to start from cold, and they could have a longer response time as a result. But Amazon have actually got really, really, really good at starting them quick to the point that unless you need sub 20 millisecond responses, don't worry about it. If you do, you're a special case. I think for most of us at least. I will admit that me and my drinking buddies over at Red Badger have been using serverless since its alpha in production for a fairly major client. And I was super, super hesitant about it because you have to kind of like ply control from me using a crowbar. I still want to be able to SSH into something and really fix it if I need to. But it was amazing. Like, even though there's lots of API changes and lots of syntax changes, it made development so fast, and the client was so happy. We didn't just like end up just like kicking them some containers. We're like, here, you figure it out. You know, it was a very bespoke, very composable, very understandable, very granular project that you could easily push to anywhere you easily update, easily control, easily monitor, without having to ever really have someone employed just look after it, because that's AWS's job. The trick to figuring out whether you're on the serverless hype train is, do you have an event-driven application? It doesn't matter what the event is, as long as it's event-driven. Do you have a short-running task, which is most of us, because most of us do websites that go somewhere, come back, usually in less than a second. And do you have your man-bun/fixie bike to join the hipster crowd? If yes, you can join the serverless hype train. All right. So that was a bit ramshackle, sorry, but thank you very much. Any questions, my friend in the front?
Yes, Fox. At the beginning there was a slide of classical architecture, and you had one database,
yes,
products and purchases. On serverless, you have two databases. I wonder why this distinction that you now have two databases.
Well, I mean, the reason we have singular databases is often for ease in traditional applications if you have to maintain them ourselves. But with each, so search function will be its own serverless function, right? And it'll define that it needs a DynamoDB instance or something like that. So they can each have their own personal database, and this is like a self-contained set. So they don't need to share. In fact, sharing is pointless. It just means there's more chance for stuff to leak between the abstractions, right? So yeah, this is trivial I think we would have separate databases too in traditional applications if it wasn't a pain in the ass to keep spinning up more and more databases and having the communication work between them.
Yeah, but if you want to make a query on both, then it's more complicated.
Oh no, then you just have another Lambda. So Lambda's all the way down, man. I hope that helps you, my friend.
So serverless framework, how
yeah.
does it deal with external dependencies?
Okay, so when you run Lambda inside Lambda inside AWS, it comes with the AWS SDK as standard, but there are loads and loads of NPM modules you want to bring with you, right? To have loads and loads of logic. You can have entire Node and Express applications inside as a Lambda, right? For a single thing, that's completely fine, and that can be very long. You can do stuff like Webpack and whatever, and it will just bundle that stuff up for you. Serverless as part of its charm does application bundling, and it'll just shove it up as a single entity to the void with all your dependencies.
Not so much code dependencies, I guess infrastructure dependencies. So in your example of face swapping, you were using recognition, you were using an S3 bucket. Have you built those manually?
No, they're part of serverless YAML. You define the bits you need and keep the permissions upon them, and they get made with them. That's the real beauty, right? It's like your infrastructure and your code are together. So you don't have to ever go to the AWS console or do a drop down or whatever, right? So in the case of here, for example, here we say it has an S3 event, and we say we have this is the resource that exists, right? So someone's got to make that resource. Serverless will take care of creating that resource for you to make sure you have the S3 bucket available.
How do you provide the S3 config?
So you can apply you can apply that separately, or here you basically just say the default is, and you say no configuration required. It's just an empty bucket with one folder inside. But you can provide that separately, yeah. So you can extend and compose your serverless YAMLs as well to have more and more detail, and this is a very basic version.
You say that AWS Lambda competition is not high quality. So do you also mean Google Cloud Functions? And if yes, why?
So Google Cloud is fine. It just offers a fewer arrays of products, I think, whereas AWS has a very broad range that can take care of nearly all your business needs at once. Sorry, I took a cheap jab at Azure because it's been winding me up recently. No worries. Thank you very much. If you need me, I'll be in the pub.